The following content has been provided by RWTH, Aachen University.
Hello everybody, welcome to our lecture today. So today we are going to talk a little bit more about details about Swift, and then we will dive into the iOS framework a little bit more, talking about how to create views, how to navigate through views, and then later on Philipp will show you how to lay out your interfaces in a way that can be displayed on multiple devices in a nice orientation. So how can you design an application that has a good orientational layout on an iPad, but as well as on the iPhone, without having to create totally new interfaces in this way. With Swift, we're going to talk a little bit about optionals, which I introduced already like last week, but I will talk about a little bit more in these details. Typecasting and inspection, how you can actually check your types and how can you work with that. The guard statement, it's a fairly new concept which was introduced in Swift, which is quite helpful. And enumerations, as you all probably know. However, in Swift they have some more functionality that enumerations usually do not have. So let's get started with the optionals. So as I already said, usually variables in Swift cannot have the value nil. There have to be some kind of value in there. So you have an integer, it always have to be a number. If it's a double, also have to be also a number. And the string can be empty, but it is still a string. So you don't have like a null pointer concept that you've known from other languages. So, however, this is not a very useful concept when you look at it first, because sometimes you want to have this concept of a null pointer because you want to use this. Okay, this part is empty, it doesn't exist. And you could use that by saying, okay, for an integer it could be 0 or any other value, but maybe there are some concepts which doesn't make any sense. So for example, here, in this case, we have a structure which is a book. It has a name and it has a publication year. And you have, you want to create these two Harry Potter versions. And you can use them by initializing them with that. However, if you have a book which is unannounced, for example, will be released and you want to use it in your structure, you have to initialize that with using this initializer. You can say Rebels of Lion and publication year. Now you have to put in something there because the value cannot exist. And 0 doesn't make a lot of sense in this case because 0 would mean this book is 2,000 years old and maybe not. So we have to think about how can we use this concept? How can we use this nil pointer option, which is fully used to that? And so we want to have something like this here. We want to have nil saying, okay, this is not initialized. Usually every other language, which object-oriented language would support this, but Swift doesn't do that because Swift says, as I said, the variable has to have a value. And for this one, they introduced the concept of optionals. So an additional concept, an additional type to each variable that can be either nil or the certain value. So first of all, it said, if you do this string var and you put a nil in there, this will just make a compiler error and say, okay, you cannot do that because the value has at some point. So Apple introduced this concept of optional by adding this question mark at the end of the variable type. So you can do that for every variable type that's out there, and that basically says, okay, this type of variable you just defined can be either nil or a certain type. So it's basically a tuple around this construction. So this allows you to work with these things. So you can actually then do all the null pointer things that you known from other languages. You can ask for these things. However, if you want to use that variable, if you see that variable, you always have to check if this variable exists, if there's a value in there. For example, in this case, if you would call the string and it's currently set to nil, your application will just crash because the compiler assumes every time you use it, there's a value in there. I can ask if nil is in there and can work with an if condition with something like this in there. But if I directly would use the variable, the system would say, okay, there's no value in there, I cannot do anything, so we'll crash. Essentially, when you would use this, the compiler will tell you, okay, you didn't check if there's a value in that optional or not. So it will run a compiler error and say, okay, you cannot use this because you first have to unwrap, that's the term, this variable to use that. So let's take the example from the book here again and say, okay, we have the book, we have a name. Books usually have names, but the publication year we are not sure yet. So how can we unwrap an optional? So how can we actually say we want to have the value inside that optional, not the null pointer? So the easiest way to use this would be saying, okay, we use the this explanation point here at the end at a variable, and this basically force unwraps that value. However, what would happen? Could you guess what will happen if the variable would be null? Exactly. So crash, basically. So this would be possible, and this would not throw an error or something, but it would crash on runtime, because if the variable is nil, maybe you're lucky the value gets never nil, so you can work with that, but in this case, it will create a runtime error and will just die in most of the cases. We will see that at some point you have to force unwrap in some occasions, but usually you should avoid using these things because you don't want to have, your app should not crash on runtime. You should avoid this. So an easy way to unwrap this is doing an if condition. Basically, you can ask the variable, are you nil or not? And if not, I can assign you to a constant variable. For example, saying, if publication year is unequals nil, then create a actual year publication by force unwrapping this. Because now you know the system, and then the system knows, okay, I'm in that if condition, which can only be true if the value is not nil, so I can use this, and there will be no message around this. However, this could be also written in a much more shorter version without having to use the if condition. You can actually say, in the if statement, you can directly define a variable directly in the if statement. So you don't have to ask for nil, but you can actually say, okay, if that actual year is publication year, what you're actually doing there is question is, okay, is the variable there? If there's a value in the publication year, then this statement would be true, and the constant will be assigned to that value. Because this constant is not optional, so it can only exist if the value inside the publication year exists, so it's not nil. So with this one, you can actually unpack or unwrap an optional quite easily without having to ask before, because you can do it implicitly by just doing the if condition here in this case. And then you can use it in the if condition. You can also unwrap multiple options. So the typical way how would you do that is like putting a lot of if statements, like and concatenate them and put them together. So you have multiple of these things. But you can also do in an easier way by just separating these if statements by comma. So what the system will do, it will first check the first one. If this is still true or if the let can be created, then it checks the second one. So it's a lazy evaluation. And then you can unpack a lot of conditions at the same time without having to do like 20 if statements in there. You will get rid of a lot of breadcrumbs. So, so this is the easy way to do that. Optional can also be used for functions. So you can actually have functions that return an optional. So you can have the typical null returning functions. However, again, if you assign that value to a variable, in this case, you always have to check. You have to do an unwrap of the value itself. So again, you would have to check, do an if statement if the value exists, even if it returns from a function here. You can also create a failable initializer. For example, if you would create a class that uses a network connection or an online connection and you don't have any cellular connection, you can create this on the spot, and this can be used to trigger, okay, check the network cannot be initialized, so I should not be able to initialize the network connection class. So a failable initializer is also possible. And there are a lot of like easy ways to use optionals. And one of the advanced things is optional chaining. So for example, let's say we have this construction. So we have as a class, it's a person, it has a variable age, and it has a residence. And the residence is another class, so it has an address, and the address has just a couple of strings and an apartment number. So these could be the typical setup that you could use in your application. However, in this case, the apartment number can be optional because maybe you don't have a number in your apartment. Residence, maybe you don't know the residence number or you don't know the address. So there you have a couple of optionals in there. So how to unpack this? So for example, you have a class which is a person, and you want to know the apartment number in this case. So the typical way would be to do, again, if chaining. So have a lot of if statements, say, if the person is a resident, so evaluate this statement here. If is this true, I do another if statement, and I'm testing if this person has an address. And if the address is existing, then I can ask if the apartment number is there. So, and then I can use it. So I have like 3 if statements concatenated. However, you can also do it much easier. Could you think about a way how you could do it in a simpler way? Similar to the if statement that we saw beforehand, you can actually do it in one call.
Just use a comma.
Yeah, basically, well, not entirely comma, because they are not really separated, but similar to that. So you could do something like this. So the apartment number. So basically, you take the person, then you take the residence with the question mark, the address, and the apartment number. So what it does, it basically first evaluates if this exists, if this is a value. If this is true, you run into this, the address. This is a value. And then the apartment number is the last call, and you basically do like unwrapping optionals in a sequence with just one call. So that at any point in this call, if this one of these values is null, the if statement would be false and it would not be triggered. So with this, you can actually concatenate then in just one call. And again, you save a lot of like code that nobody wants to read. So this is optionals. You will see them a lot. Every time you will use some kind of function that uses network connections. Every time you use some kind of elements in the UI kit itself, which is uncertain if the object exists or not, you have a lot of functions which return optionals. So you have to deal with them quite often. And every time you are uncertain of a certain state or something, you should use the optional property to make distinction between if the object exists or not. So yeah, this is the typical handle, and you will use them quite often. So let's talk a little bit, go further and talk a little about typecasting, because it's somehow related in this case. So as I already said, Swift is extremely strong typecast. So you have to even cast between an integer and a double if you want to add them or something like this. But how can you actually do typecasting in a way? So let's say we have a superclass which is vehicle, and we have car, which is a subclass, and then you have another subclass which is motorcycle, and you get an array of this function, and you want to have a variable which gets you all of the vehicles that you have. How can you actually check the object inside this array? Could be any of these things. How could you actually check that? So the simplest way would be for asking this, and this is the keyword as, what you have, and with the question mark at the end. So this is again another if statement. So for example, let's say if the car is a vehicle from type car, then this statement is true. So with the as statement, you can actually ask, is this instance of the superclass vehicle, is that actually a car or not? This would only be true if it's a car or not. The same way you can also do with a motorcycle. And so basically you can ask again and have basically the same concept as from optional. So the if statement is only true, or the let only has a value inside this thing if it's true, and then you can do like an if statement and ask for each of these values. So you can also do forced cast. So you can also not ask for are you a certain type of an object, but you can also say you should be a car in this place. Again, danger here, if it's a motorcycle, it will break, because it's a totally different structure, it doesn't know that. But you can actually do that if you're really certain this is the type of class and you don't want to ask for this. Sometimes you have some callbacks from your iKit, you know from which type it is, so you can actually do that. However, again, it's a cast which you force. If you got something wrong, your application will just crash on a runtime error. So you should be very sure what you're doing in this case, because you don't want to crash your application. So there are also these superclass types, which you know from other languages. For example, in Objective-C, there's this object type, which is the superclass of every class that you create. And these are the any and the any object type. And the any type is basically everything. So you can create an array from type any. You can put everything in there that you want. Everything that you create, your custom classes, your structures, everything can be from the type any. So this would allow you to create basically an array of any element that you like. However, now you have the hard time to figure out, okay, what's the item in there. Every time you call an item, you have to be sure which type it is. So if you ever use the any statement, use it carefully and wisely, because this saves you a lot of code to create like an array which contains several elements. But every time you want to use an object from that array, your if statement to check which class it is gets really, really messy, because you cannot really identify which type it is. There are some ways to do that using generalized applications, but however, this is very complex and is usually not that hard. There's another construct, which is any object. And the difference between any and any object is that any object are just classes. So structures are not included in this one. So this could be used for if you want to have just an array of classes, you want to use that. So this is basically the option. However, every time, usually most of the people I've seen using any at all, if you use that, they use usually any and not any object. Because since structures are very similar now to classes in Swift, you usually see a lot of people using structures and not objects anymore, because they're a little bit smaller from the memory space. Okay, this is a little bit about typecasting, and it works for every class in the same way. The next point I want to talk about is the guard statement. And the guard statement is basically an inverse if statement with a little twist which makes it very usable. So usually if you have a function that say happy birthday, in this case, and you have a lot of like if clauses encapsulated in one thing. So for example, if your birthday is today and if you invited guests and you have a candle lit, then you can happy birthday to you. And so you can have a lot of if statements or a lot of if else conditions combined together. And it's usually pretty hard to read, because now what's the scope of, for example, this one? So this if statement has just this scope, and then you have to figure out, and this is hard to read. You should want to have it read it in a more easier way without that many brackets and without that indents. So, and the guard, therefore the guard was introduced by Apple, and it's basically saying you have a condition, and then you don't have the what happens if the condition is true. You have just what happens if the condition is not true. So in this case, you say, okay, if guard condition else, inside the bracket, you can return or say something else when the value is not existing. And after the bracket, you can actually say, assume that condition is true. So with this, and this is basically the same thing as here, but now with the guard statement, you see that it's very much more easier to read. Because now you can say, is my birthday today? If this is not the case, so no one has birthday today, so you can print that out in an easier way. And so you don't have to do this encapsulation of multiple else statements or if and else statements in a way, so you can read it much faster. And here at the end, you can assume all of these statements that I just make are true. So, and another thing that is really nice about the guard statement is the scope of the variables. So usually you have an if statement, and what happens if you have, for example, if you define that let the x in there, the value only exists, or the let is only available in that bracket. So every time you leave that bracket, the egg doesn't exist anymore, because the scope of that variable is just for this specific if condition. However, in guard, this is not the case. In guard, you can basically define this variable and assume that afterwards your condition is true. For example, say, let me define that x, and now I can, in the entire function, I can use that constant variable as x. So you can basically define a lot of guard statements or constants at the beginning of a class, and then for the rest of the class assume, okay, they all exist. So what you will see in a lot of Swift applications, for example, you have a function that gets 5 values, and you need to check some parameters of that value. You see at the beginning some guard statements that exclude all of the things that you want to avoid. And then for the rest of the code, it's basically assuming, okay, all of these conditions are in the right set, and I want to use them in the same way. So for example, like this, you have the guard statement, and you can actually also combine them again in the same way as for the if statement. So let's say, okay, we have a process block, and I want to check if this is a title, if this is a price, and if this is a page. So we have these optionals, and I'm basically unpacking all of these optionals at the beginning of the function call. And if one of them is nil, I don't want to use that function at all. I want to say I'm just returning that function. So basically, after this bracket, I know that all of these optionals have a value and I can use them without having to think about, okay, what's the scope of that variable? What's the value of that variable? So then you can actually use them at the beginning. So you will see a lot of functions where you have at the beginning basically a gigantic guard block, and then you can assume the values that you have. That makes it much more easier to read your code, and it structures your code in a nice way, saying, okay, I want to get rid of all the conditions where I don't want to use that functions, and afterward I can use that function quite easily in a way. Okay, this is guard statements, so think about them as a reverse if statement, and you will see them much more often. So let's talk a little bit about a different type that we also have. We talked about structures, which talked about classes, but there are also enumerations, which are some kind of type which have only a limited set of values, for example. But there should be also introduced, does anybody not know what an enumeration is? Okay, good. So I can assume talking about this. So enumerations are basically type-fixed objects, and you can say, okay, I want to have a compass point, north, east, west, south, and I can just define them. And how I can use them is basically using this variable and can say, okay, this is from type compass point, so this enumeration, and it should be that west value, and you put it with a dot and west, or you can actually do this as an initializer. And you can also update them in the same simple way. However, you can also have, and usually they're used for some kind of like type safety benefits, because at some point you say, I want to have a certain string, and the string should be only have a certain values, but you cannot basically avoid that using a string, because a string could be anything. However, in an enumeration, you can actually define, as I said already, it could be some specific values to help to narrow down the list, and you don't have anything weird in the string that you don't want to use in this case. So for example, could be something like this. You have a movie, and you have a name in there, release year, and a genre. And the genre should be a fixed value, because maybe you re-implementing IMDb, and you want to sort them in a way, and you want to define that variable. So if you have genre as a string, yeah, you cannot avoid this, because this would be a valid value, Tom. It's from conceptually, it doesn't make a lot of sense, but the compiler will not say, okay, I'm string, I don't care. So you could also define this as a genre case in this case, and say, okay, I'm only allowing these kinds of genres. So I can limit the type in there dramatically and say, okay, this should be just this animation thing. So, and you can also say, okay, this to convert this, you can actually say the enumeration should not be only a certain type, but it can also be some kind of value type. So you can say this enum should be a string. And you can actually then convert easily from the enum value to that string in a simple way. Or it should be an integer. So basically what the system is doing that, okay, this is value 0, and you can actually then convert it into a different function if you need to. However, for easily readability, you can actually just assume these things. So these are very small details about Swift, and we actually want to go a little bit more into programming. So what I will do now, I will show you a little bit how you create your first application, how you do multi-view. As I already said, you have a lot of views, and we will start out with a very simple application where we just show you how to move from one view into multiple views using buttons, or very simple, the navigation bar controller, which is one of the most commonly used controllers that you see, which you will see in most of the applications. So for this one, I will do a lot of demoing, so we'll sit down. Oh, I have one additional slide. So what we want to do is basically you have these multiple views. Let's say this is my contact view. For example, I have all the list of people in here, and I want to click on one object. So we want to look a little bit into how we can actually switch between different views. How can we move from one view to another? How we can go back, and how you can create like a chain of different views and a chain of different functions. So with this one, I will do a very simple demo. And Philipp will later on explain you how to fill these things in a nice way with buttons and animations. So let's go into the Segway demo. So this is just a totally new application. So I just created it. I created a single view application with no content inside. So currently the code is it's nothing there. However, when I start running it, yeah, nothing really happens because, yeah, I didn't do anything with that. So as you can see here, as Philipp explained, showed you later, or yes, last week. Let's switch to a different device here. So this is my first view. How to get rid of this again? There you go. So this is my start view, and this is what happens if I start the application. Nothing really interesting. So if I want to create a different view, I can just use that by saying, okay, I want to have view controller, in this case. So this is my second view that I have here. And let's say this should be, for example, the detailed content. So this could be a contact list. If I have a list of people there, and I click on one of these people, and I get a detailed view, the address and the phone number. So the typical thing that you see. So one thing how you can actually change from one view to a different view is by using a button. So let's say, let's put a button in here. And the simplest way to do that is to do a command thing and say present modality. And what happens, I create these little segue. So this is basically the connection between these two different views. And what happens now if I run this again? Let's see. So nothing really, because they have the same color. Let's change the color to make it a little bit more readable or visible what happens. So let's say this is green. And let's keep that white. So you see, okay, this is the way how you can switch between different views. Now you could design your different applications or different parts of your interface in these two different views. So now I have to think about, okay, how do I get back? So the easiest way to do that would be to just say, okay, I have a button here. And I do the same thing. I press Control, click, and drag it back and say, okay, present this back, and you get another connection there. So that you run this now. So I get a button and I get another button. So I can switch between these two views. However, as you can already see, I just created two views, and it gets already pretty messy. So think about if you have like 20 views or something like this, the storyboard that you have in this application here will be horrible in a way. And that's some ways how you can get around these things. First of all, you could program that on your own if you would like to. So you can program the entire thing if you want. Yes? What again?
How to make the new window.
The new window. So basically you click on this one here, and then you click View Controller. You want to have a view controller. So the view controller is basically the part where you create a view and the code part. We will go into that also as well. So I can also do that programming. I can say I want to connect these things. However, there's also an easy way, at least for the back button. There's something like the system can unwind the function that you just did. And I will do that in code by basically saying, okay, let me create a function here. Let's call it IB_action. So does anybody remember what the IB_action command was for? Yeah, but not only a button. IB_action command basically says, okay, this function, I want to make it visible for the storyboard. So the IB command basically tells the system, okay, I need to have a connection, and it will be visible in my storyboard. So I can actually connect something from the storyboard into my code. So this is the way how you do that. So this is a function, and let's say unwind to make this happen, and I say for a segue, yeah, let's call it unwind segue, and then I give it a UI storyboard segue. So this is basically the class of this connection that I just created. So that's basically it. So what I now have to do, I have to connect this to that thing. Yeah, the new. This is a little bit messy, but this is the view I want to have. This is hard to see for you. So basically what I have now is, how to get rid of this one. No, wrong one. Is basically I have, on the one side I have the storyboard here on this side, and I have the code, the representing code of the other side. So what I can do is basically I want to connect this to this function. I could drag it inside the code, but I can also drag it to this little tiny object there, which is hard to read. However, now you can see, okay, this is my function. Can you actually see that in it back? So unfortunately, I cannot make it much bigger, but it's actually the same name as the function I just called. So this is unwind and then the function call. And what I'm doing here now, I'm connecting this to here. Okay, why does it change? Let's set it to manual. So what I now did, I basically create an unwind thing to don't go back to the previous one, so don't to a specific one, but I can use that to go back from any sec where I came from. So I can use it as a bug function and can use just one function to have like 20 of these connected together, and I'm just calling the unwind thing to go one step back. So it's not, I'm not going back to a specific view, but I'm going back to the last one that I have. So again, doing this one and going back to this one. So I can, every time I create a new view, I could just create another button that connects to the same function. So this is just -1 step, basically, going these things back. So, however, this is like a little bit tedious. Yes?
How you define the event, for example, is when it's pressed or when it's long pressed or when it's, I don't know.
Okay, this we can go into this one as well. I will create another function just to show you on. So let's say I'm creating this thing here, so I control click inside here. And this is, again, hard to read. So basically what this says, this is the one thing I want to create for this connection. I want to have an action, which is basically from the button into the code. But I can also say I want to have an outlet, basically, that allows me to change the label of the button. So this is the other way around, as we explained last week. Outlet is basically the code could change the name of that button. So you have these two connections. Then I could say, okay, where should it be addressed? It should be in the view controllers, because this is my class where I'm currently in. Then I can give it a name. So let's say button pressed. And then I can define the type of the function, that the parameter that I just give them. For example, I can say any, then I will use it as. But I can also say, okay, this function should be just called by UI button. The good thing about this, now I could use this function to change a variable of that button, because I get a link into the button. And then here's the list of basically what I can do with it. So basically, you could say touch on ups inside. So here I can basically define the behavior when this action should be triggered. So in this case, it's touch up inside. So basically, I touch it, and I'm still inside. When I release the finger, this will be triggered. So when I, for example, touch it, move my finger outside, and then release it, would be not triggered. But you can basically choose whatever you want. The standard one is by releasing. So usually on a mouse event, you make a click as soon as you click. Whatever you do afterwards doesn't really matter, because you go into a dragging operation or not. However, on touch, it's usually that UI element just reacts when you release your finger, because you don't have this normal state with the mouse. You can hover above an object and see what happens, for example, a tooltip. But on touch, you don't, because when you trigger an event, when you just touch it, you couldn't do some hover or something like that. So it's usually a release function. This is the typical thing. And you could define that in the same way. Okay, let's move on. So let's keep this here for now. So, but usually you want to have like a lot of connections together, and this is like not the nicest way to do. And actually, there's one common controller that you can use for doing these kinds of step navigation. So having like an overview, then a detailed view, and maybe then a third detailed view. So you have this chain of UI views together. And this is called the navigation controller. And you can add them by using basically a view. It's called navigation controller. this will create a new controller where you can hook in a lot of different controllers. What I will do, I will now transform this current setup into a navigation controller by basically selecting the first one here. Now it zooms in. And saying, okay, edit. No, it's edit, embed into, oh, I've selected the wrong one. Navigation controller. Now this setup. So, yeah. This screen is too small to show everything. So what it happens is now you have this chain of view controllers. So this is the basic controller. So this is basically a top bar that you will see in a lot of applications. And can you actually see that? No, you can't. That's the. Let me change the color. We need a new projector for this one. So just to make it sure to see, okay, this is just a template class. So this view doesn't really exist. It's just a top view here. So in every view that you now connect into this one, you will get this top view here. This is currently not correctly connected. I will do that later on, but you will see you have this top bar that you've seen from a lot of different applications that you can use here. And what you here see, this marker, we didn't explain that, this is basically the hook endpoint. So this is the first view that is shown when you start your application. And you can actually select that on the side here, on this side menu here. You can click on a certain option and say, okay, I want to start here. So let's change that back to a different color to make it a little bit more visible. Let's take just this one here. So let me get rid of this function. And now I can actually say this button, what did I do now? Should show me that. And what happens here is it creates the connection here and says, okay, I'm currently in my navigation controller, and this button here should trigger this view. And what happens is automatically you create another top bar. So the top bar is created for this view, and you get an automatically back button. So I didn't do anything for that. This is automatically created to give this back options here. Let me start this here. So you see, I'm starting with this one, and I'm clicking on the button, and I can say, using this navigation add. And I can add hundreds of them if I want to. And I'm connect them in the same way. In the same way to get this information to them. I can also change that. For example, there's this navigation item. So let me put a title in here and say this is green. And this should be, let's say this is blue. And you already see that the back button, let me zoom in, the back button already adapted to the title. So it's not back again, but it's basically saying blue. You can also add a typical button in here. You can also say something if you want to have like a search button or something that you can add buttons into there that is like for maybe create a new contact or search in that list. So there's this whole option of defining that thing. Let me put that here. No, this is the wrong one. The new interface is a little bit weird. Yeah, for example, I can use this and I can have an item here, or I can select a certain let's say I want to have an add option or a done option, so you can use the typical applications and they have the typical behavior or search objects in this way. And so you can add additional functionality in it. For example, on the plus option, you can also say, okay, this should be a segue into a different view. So to show you that it actually works, let's add another view. This is, again, a typical view controller. I put it here. Come on. Let's make it hello. Make it red. And again, I want to have show this content, and it's automatically integrated into this thing, and it basically allows me to go back again. So button, I press this button, I press the next button, and I go back to these different labels. So you have like some kind of connection between these things. So now we have these different views, but now we have to think about how can we get information across these different views. So how could I, for example, if I select Philipp in my contact list, how can I tell the next view my information? So how can I move content or information from one view into another one? And for this one, we just do a simple demo here. Let's say I'm creating a text field in here, so I can put in some text here, and let's say I'm creating a label here. And what I want to do now is, as soon as I press the button, I want to have the information from that text view. I want to have this in the label. So I'm transferring basically a string to a different view. And this can be easily done by, now you have to write a little bit of code. Basically, first of all, we have to connect this label into my view controller. So basically, again, this drag operation. Let's do a different way. It's easier without this. So basically what I want to do, I want to change the name of that class. It's simpler without this. So basically I want to have the value that which is in here should be the name of that class. So of that view. So this has to be done in code. And what I can do now is I'm overriding a function that is usually called where I want to transform from one view into a different view. This can be used for doing a custom animation. For example, if you want to say, somebody pressed the button, I don't want to have that swipe animation, but something else, you could change that. But for now, we will just override a function, basically, that allows me to transfer information. So you have to use the override statement here. And the function is called prepare for segue and any sender. So now this function is called as soon as I click the button, the segue is executed, and this function is then called when I start transferring this information. So what I can do now is I get the segue, so the connection between these two views as a parameter. The connection has like a starting point, and it also has a destination. And these are the different viewports in this case. So and what I want to do, I want to change the label of the destination. So what I can do now is, let's say, segue, give me the destination of this thing, and then navigation item. And this navigation item has a title, and it should be saying, let's do it. I'm just putting in the name here to show you that it works, and I will later on connect it to the view, to the text view. So this basically allows me to transfer an information, and you can also say, okay, the different view has a certain variable, and I want to put a value inside that variable, something like that. So basically, you can call while you're clicking this step to get this in. So in this case, I'm pressing the button, and now it says basically hello, because I changed the title as soon as I clicked that button. So this is not transferred directly when I start the application, but as soon as I press the button. Okay. So since we have not a lot of time anymore for this one, I will do another demo thing to show you how you can actually choose between different segues. So for example, let's say I don't want to go through the red one while I have to go through the blue one. Maybe I want to have them at the same time. Or I want to choose, I have multiple buttons in this blue one that allows me to go directly to the red one without going into blue one. So you have like some kind of not like a sequence, but you have some, they are grouped together. And this can be also easily done. So what I will do, I remove these segues, and now I have to zoom out a little bit. And get rid of this one. And create another button, so I can just copy this button here. So what I have two buttons. Let's call this one red and this one green. So now I have to create the connection between these two things. And one easy way is to do, instead of like connecting it to just a button, so I don't give the button the connection, I create a connection between these views directly. So I can click on this blue thingy here and drag it over here and say show. And same thing for here. And now I have these two segues here. These are the two connections between these things. And the important thing that you have to know is that every object that you create in the storyboard has an identifier. So it's usually not set, but you can use it, and you can call any of these things with a certain identifier. So this is the label here. Basically, you can put any string in there you like, and then you can actually call from the code these identifiers. So what you can actually do, you can give an identifier to a button, and you could actually ask the storyboard, okay, give me the button with the certain identifier. You can do that with every component in there. Every view you can give an identifier, basically anything that you like. Even animations or the drag and drop gestures that I showed you last week, you can also drag them in, give them an identifier, and call them from your code. So this is basically what we'll do now. So let's give that the name green from this one, and I will call this red. And now I have to go back to the code to create these functions here. So what I will do, I will just show you it for the green one here. And I'm creating a function call, let's say, switch to green is my function. Switch to green is here, so this is basically called if I press the button. What I can do now, instead of like calling, I have to call a specific function that does this transformation. So in this case, the function is called perform, where is it? Perform segue. Yeah, let's go to this mode. So, and it asked me, so the function needs a string, so this is the identifier I want to call, and it needs to have a sender. So basically, that you can refer to that if you want to go back. However, you don't have to do that in this case. So in this case, I will call it green, and the sender can be null, because I don't want to tell another segue that or another viewport that I just used this button. So with this function, you can actually then decide on code which segue should be executed. And with this, you can actually have a lot of different stacks to get connected together without having to have this sequential hierarchy. You can actually have like groups and all of these things, so we can create gigantic trees of different viewports. And if you look at a lot of big applications which use these things a lot, they have a lot of viewports, basically for everything that you use in a certain way. So this is the first step that I want to show you, to look into the connection between different views. And what we're going to do now is to show you a little bit how to arrange GUI elements inside one particular view, how to make them, that the layout will be in the same way, similar on different devices. For example, I want to show you something on my phone, which is an 6S. It would be on different positions than, for example, on a 10 or on the iPad as well. For this one, Philipp will show you a little bit of Autolayout Magic.
So, like we said last week, the different devices have different resolutions, different aspect ratios, and stuff like that. So if I would just place a button or a label on the screen, it would not be necessarily at that place, even though I use here these lines that it's centered, if I would show it on a different device. And you can already preview that without having to start the whole application with these view as options here. So if I switch here, for example, in the landscape orientation, you see, okay, the label is definitely not centered anymore. But Autolayout helps you design user interfaces that adapt to different resolutions, to different aspect ratios. So for example, for this label, I have here in the bottom right of the interface builder a couple of options. And one of them here is the align tool. And I can select that, and I could set up here how the label should behave in response to different elements, different labels, different views I have, or how it behaves in relation to the container. So here, if I just select that it is horizontally and vertically aligned in the container, I could also set here a value, if it should be 10 points more, 20 points more, whatever. If I don't enter something here, it will stay in the center of my container. If I just add those constraints, you can also see I now have here these blue lines that say, okay, these constraints are set. And that's basically everything I need to do to have this label stay centered on whatever screen I show that. So an iPad, iPhone, and in the different orientations. So, but that so far only adapts the position. So the size of the label actually does not change here. Let's make a background so you can see that. So the size of that whole label is essentially now determined by what is inside. So if I have here something, you can see it jumps back now that it is centered, but the size increased. But I can also set the size of my label here. So for example, this element here adds new constraints that are then related to sizes and distances. So if I would say here the width of my label should be, not 20 points, let's make it a little bit bigger. Set the height to 200 points. And it now is conflicting with another one. I will get to how to resolve conflicts and see them soon. So let's just edit that here. So yeah, that just updates the height, and it still stays in the center, but now the height is set to 200 points. And you can see all the constraints that are attached to a object also in your inspector here. There's the tab for the different sizes, and down here you have all the different constraints that you can edit and determine, well, how do you want to change the values. So for example, if I want to have it not 200 points, but 100 points, then I can directly adapt that here. And should the interface not match what you set in as your constraints, or you want to update it, there's this button that's currently grayed out here that will update the view you have here, or that is visualized here in the interface builder, to the constraints that are currently set for your UI. So for the width, I could do a similar thing, just set the width, but with these elements up here, I can specify how it should behave in relation to the screen or the view you're using it in. So if I said here, yeah, it should be 20 points from the left side of the screen. You can see that maybe not on the projector, but yeah, it's actually visible, that this is now not a dotted line anymore, but filled out. That means, okay, this one is now will now be set. So and if I add this one constraint, it is now 20 points from the left. And it's also doing that from the right because there's still the constraint that it should be centered. So if it comes closer to the left edge, it also needs to come closer to the right edge. And that is adapts as well. Now it has a dynamic width, so to say, based on the size of the device that you're using. So you can see here at the top there is the status bar. So if I would add another label here, let's give it also a background that's easier to see. And what I could do, or what you should not do, is put it directly behind the status bar, because I mean that would not be visible if there's a time and everything showing up there, that you couldn't read what is in your label down there. And Interface Builder has this save area that helps you to adapt for these for the status bar or other changes in the screen size based from navigation controller, for example. You saw that this has a navigation bar there on top, or a tab view that has a bar there on the bottom. And so if I color this in or just select that, you can see the whole view covers the whole screen, but the save area has this area here on top excluding from that. So what I could, for example, do if I attach this label and say it should have, should be at the top of my view here, and I add that constraint, then it will always be attached to the top of the save area. And to see more what it is aligned to, if you select here in the inspector the constraint, you can also you can see what the constraint is actually connecting. So here the first item is the top part of my label, and that should be equal to the top part of the save area. And I could adjust this here to be what it should be attached to. So I can adjust that here. So now just to show that, if I embed, let's do it here. If I embed this in a navigation controller, you can see that it automatically jumped down and is now underneath the navigation bar. So that is something, if you design your UI in relation to the save area, that can help you react to system events that change your UI as well. So, as you already saw, we already had a warning or a label when I added two conflicting constraints, and so what could happen there is, for example, if I say we already said that it should be 20 points from the left, but if I would say, okay, but it should be 60 points from the right, then here you see that we have these red lines. So that's essentially a conflict, because it cannot be 20 from the left, 60 from the right, and stay in the center. And similar to warnings you have in code, you have this marking system where you have also suggestions from Xcode how to solve this error. So here I can essentially select which constraints I want to keep and which ones I want to remove. So for example, if I say here, okay, I'm not caring about that it is in the center anymore, and I delete that constraint, all my warnings and all my errors here are gone, because now everything is possible to be set up and laid out based on the constraints that I set. Or if I remove or move this around here in my view, so that essentially what I have set as constraints does not match anymore what is now shown here, then you see here this bar where it's supposed to be, but I also have this warning that that tells me, okay, yeah, what options do I have to resolve that? I can update the frames, essentially what this button down here does, and it would move it back to the location where the constraints suppose it should be. Or I can update the constraints, so the values that I have set here to match what is now visible there on the screen. Or remove every constraint that is currently in relation to this view, and then add new ones. So the difference between those is, if it can't here, it just tries to adapt the values. So if I said, okay, it should be 20 points from the left, and I moved it to be 30 points, it can update that. But maybe there are movements here that it can't just adapt to with just adjusting values to existing constraints. Then the last one will also add new constraints so that it fits that. And yeah, this is not something that works all the time. Essentially, it's hard to for the system to determine, well, what was your intention, especially for the relationship then, if it's centered or placed, how it should be then in, on different screens, whether you intended something to be in the top left all the time, or centered in the on a smaller device. It's sometimes not that easy to distinguish. So try to set everything as well as you can. But there are different options how Interface Builder can help you with that. So, and most of them are also listed here for the resolve auto layout issues. And similar to those that I showed you, updating the constraints, the values that are in there, can add new ones, or you can select here that should just add constraints. So that is often the case if you just set a height for something and it is centered horizontally, but it doesn't know, okay, what is the width that I now need to have. Reset to suggested constraints, remove everything and adds new ones, and clear constraints just removes all the constraints that you currently have. So have I set everything here? Yes. So now if I have multiple labels, that was not. So let's add a couple of labels here. Not 19 yet. And give it a background so you can see it more easily. And I want to have this one centered. Where did that? And attached to the top. And now I want to have another label that is 20 points underneath that. And so what I could do, also let's give it a background. Yay, auto layout is fun. And that should be 20 points from the other label. So I just enter here the 20 points. And these constraints are always in relation to the nearest view that it can find, or the nearest other element it can find. So if I add 20 here, it will now be in relation to this label that we have up here. So that is now 20 points underneath it, but it doesn't know where's the X position of this. So what I can do, for example, or to show the other aligning options, if I select both of these here in my alignment, the other options are also now possible to select. And now I can set, okay, I want to have them that the horizontal centers are the same. And now it jumps down here. So now another label that I want to add. And you can already see this is becoming tedious to write, because there's a lot you're doing multiple times. So 20 from the top, and these two should have horizontal centers. And let's just do one more, adding this here. No, that was. And another background. What can we see? That one. Yeah, I can't read it, whatever. So 20 from the top, and these two should be aligned. So, and now the problem is, if I would say, okay, my view should, or it would look better if there are 30 points. I would have to go back there and adapt every one of these distances here individually. So, and there is an easier way how to combine that. And that is what's called a stack view. So I can select all these options and the last item we have in here, and embed that in a stack view. And what that does is combining all these 4 labels together in one item that I can then place and adapt. So if I combine them here, I now have here my stack view where all the elements are in. And I can control this stack view as I would another element in my view. So if I say from the height should be the same, so it's split over the whole distance here, and I want to have 10 points from the left, 10 from the right, and now that was, and what else is missing? It should be attached there to the top. So what is still missing here? Those are things for inside. So the stack view has a couple of options that I can set. So the first one here is whether the alignment or the order of the elements inside should be vertical or horizontal. So if they are side by side this way or just stacked. The alignment, similar to the alignment of text in a text view, this is now centered. I could set it to fill, that it is over the whole, that was not well, that it is over the whole width of the stack view, leading, that it is on the left side, trailing on the right, but yeah, let's stick with center. The distribution is how the different elements are spread over the stack view. So if I set it to fill equally, then it would have all these sizes here have the same size, and for it proportionally would look for elements if they are wider or have a higher width, that is constrained and similar to what it will be adapted now here. Equal spacing doesn't change the height of the different elements, but places them in equal distance from each other. And equal centering looks at the centers of the views are spread equally. That is, so the equal centering is helpful, for example, if you have it in a horizontal stack view and you have sort of like a table, and you want to have each column having the header at the center of that, but the center at the top, the distance between them varies depending on the length of the header title that you have. So equal centering could help that the distance between each element there stays the same. And then we have here the spacing, which determines the distance or the space you have between your elements. So if I would set that to 0, everything here would not have a distance, and I could change it. So that makes it a lot simpler compared to setting up these items one by one and then having to adapt it all the time. So what else do we have? So this stack view, you can also embed stack views in other stack views. So if you have a calculator example, as I think in the book, can help you to set up the keyboard for that quite easily. So now other differences. So this was now about the placing of objects, but you can also add more information how it should adapt to different devices. So what you can see here, for example, is this weird notation that is behind the iPhone 8, and that is, belongs to what are called size classes. And size classes group basically the different devices into compact or regular, width or height. So the iPhone 8 has a, for example, here, can you all see that? Yeah. The first one here is the width, says now a compact width, and the height is set to regular. While on an iPad, you have both the width and the height regular, and if you, for example, go into a landscape orientation, that the width and the height are of the compact size. And you can also specify your elements based on these size classes. So you see here the different plus signs beside your items. So, and if I click that, I can include a new variation based on a different size class. So, for example, if I would say I want to have a variation for a regular width and regular height device, and there the spacing should be 40 points, whether that makes sense or not. You can see if I switch over to the iPad, I have way more spacing here between my elements, and so since I have a split view, these are also then have a different size class. So this is when I have a tablet in 2 apps at the same time on an iPad. The size classes there are actually different. So if I have this split view, it's a compact with regular height, while the full iPad is regular with regular height, and you can see that the distance switches between them. And that works for a lot of different elements. So if I would say, yeah, in the landscape orientation, I don't have that much space, I could select this label here, and there's this installed property. And I could there say, yeah, if it's a compact width, compact height element, then I don't want to have this one installed, this label. So that means if I switch over to the landscape orientation, that item there is not shown anymore. But yeah, and you can adapt things to that. So there are a couple more things you can do with the constraints. And for example, what you already saw, if you go to the inspector, you can edit the constant, and so far we've only worked with equal operators, but there's also unequal, that is lesser than or more. You have priorities that you can set. So currently they're all set to 1,000, which essentially means, yeah, this needs to be in there. But you can also have lower ones. And so if you have conflicting or constraints that don't work together, these priorities can help which one the interface builder should follow to adapt the layout. And the multiplier can help if you want to resize basically, or for example, on different, the size of different views. So if I want to have one of my views twice as large as the other one, I can use here the multiplier that then helps to adapt this. If this one view increases in size, that the other one basically takes twice that amount of size in there. And that if also for the different screen layouts, resolutions also in here. So other than that, that's so far for the demo. Are there any questions about auto layout that you have from just looking at that? And it is something that takes practice. So you can set or lay out your UI, and then you start it and it looks horrible, and you have no idea where to start to set it all up that it looks all right. So starting with something simple like this can give you an idea and feeling for how it behaves, and then you basically learn with more complex UIs how you need to set it up. But then it is quite powerful, and you need to do that if you want to develop for this whole range of devices, because they introduce new device aspect ratios now annually, basically. The first years it was just one resolution or aspect ratio that you had, so it was possible to set it all up in the interface builder, and it would look good on every device. But with the new devices, it's a lot more trickier. And if you have these split views in there, even more so. So yeah, go to the pool or take your laptop and try it out a little. Maybe one of you creates a UI and the other one has to set it up and develop an interface builder, and yeah, just practice it with that.
This content was provided by RWTH, Aachen University.